Great, thanks. It's great to be here. Fortunate that I'm able to come up here and talk about what I do for a living, working for UW Extension. As Steve said, I'm based out of UW Stevens Point, which is centrally located. I think that's really key for doing private well work in that I'm able to get to any corner of the state in about 2 hours, 2.5 hours. Makes it really easy to work with communities all over the state of Wisconsin. So I think location has really benefited our center and the work we do. A lot of the other presenters talked about well water outreach and education. I'm going to talk about that too, but I think I'm going to focus mainly on kind of the data collection and data archiving and sharing efforts that we've done. So I think it's going to be a little bit different than what we've heard previously, which I think is a good mix of outreach that all of us work on. So just a little bit of background on Wisconsin. Groundwater, we have a couple major aquifers. We have a crystalline bedrock aquifer, not really an aquifer, it's kind of our groundwater basement. In the south, that's maybe 2,000 feet down. In the north, it's probably the uppermost bedrock layer that most people are going to encounter. We have a sandstone and dolomite aquifer, varying levels or varying layers of sandstone and dolomite in the southern 2/3 of the state. And then we have on the eastern shore, next to Lake Michigan, we have a Silurian dolomite layer. Overlying much of the state, we have a lot of sand and gravel that was left over by the glaciers. So this was a glaciated region. Sand and gravel is the primary aquifer for a large number of Wisconsin residents. When we look at what makes Wisconsin unique, it's that we're fairly water rich and groundwater rich in particular in comparison to many other states in the United States. The blue areas are those rivers and streams that receive more than 50% of their overall stream flow from groundwater. The red are more runoff. The yellow are about 50-50. But there's a strong groundwater surface water connection that tells us that the groundwater is relatively close to the surface. So like Pennsylvania showed, average well depth is quite shallow compared to what I'm sure a lot of other states are dealing with. Average well depth is probably between about 100 and 200 feet. A 300, 400 foot well is going to be pretty unusual. And a lot of times those deep wells are crystalline bedrock wells where the well is just simply serving as a reservoir because the well has a difficult time producing enough yield. And that red bullseye in the kind of center part of the state, that's an area which we would consider to be groundwater deficient because there's not sufficient sand and gravel before people are going to encounter kind of that crystalline bedrock aquifer. As we all know, geology, land use dictate the groundwater quality. So I just wanted to give kind of a background on some of those geologic layers. This shows, again, that Wisconsin, Minnesota, Michigan are pretty unique in that we do have a really strong groundwater surface water connection. So I imagine a lot of the issues that we're encountering are similar to some of the things that our neighbors are encountering. Groundwater is valuable to Wisconsin. So 95% of Wisconsin communities actually use private well, or not private wells, but wells as their municipal water supplies. A lot of our southern neighbors are using reservoirs. Reservoirs, surface waters aren't very common in Wisconsin unless you live next to the Great Lakes. So many communities, in addition to all private well owners, obviously, and that accounts to roughly a third of the state who's relying on rural private well water. There's estimated 900,000 to 1 million private wells in the state of Wisconsin to serve that population. So in total, it's about 3/4 of our state's population that relies on groundwater, with a high percentage of those relying on private wells. The map on the right shows new wells constructed by section since 1988. The map goes from 1988 to 2006. That's the last time I updated it. During the housing slowdown, 2008 to the early part of this decade, we did see a significant slowdown in new well construction that was tied to the housing industry. That started to pick up. So I would say that since 1988, we're probably looking between 300,000 and maybe 350,000 wells that were constructed in the last 30 or so years. 1988 is kind of a magic number in that that's when our well constructor reports went digital or began to be archived in a digital database. Prior to that time, there were well construction reports available, but they're kind of in the black hole of the scanned PDF version. They're much more difficult to locate. There's not good legal description or locational information. That makes it difficult to really utilize that well construction information effectively. So 1988 is kind of a good cutoff where we have fairly good well construction. We have unique well IDs, a 2-letter, 3-digit code that each new well is going to have. That after that time period, we can locate those pretty effectively. You'll see that surrounding the municipal regions, kind of the Milwaukee area near Madison, the colors are different. That indicates more wells. Because groundwater is so easily accessible, it kind of promotes maybe what we would consider to be irresponsible well water use, in that it's not unusual to have one or even smaller acre lot sizes, 1 or less than an acre lot sizes, where you have people with private wells and septic systems, where we know based on testing that nearby effluent is influencing somebody's water quality. So I think for those reasons, the fact that water is easily accessible, it's fairly close to the surface, it's relatively clean, not a lot of natural contaminants, generally speaking. We rely on it pretty heavily, and sometimes I think to a fault. Why do people test their water? Obviously a number of reasons. The reason why most people participate in our educational outreach programs, they just want to know if that water is safe to drink. As of 2014, there were some additional testing requirements. Prior to that time, the only time it was required to be tested was time of construction, and that was for bacteria. As of 2014, new wells are required to be tested for nitrate and bacteria. And if there's ever well or pump work done, if the well is serviced, or if there's a well inspection done at the time of property transfer, it's now required to be tested for nitrate, bacteria, and arsenic. And that gets to some of the questions about drillers' concerns about testing for arsenic at the time of construction, and their concerns that it might not be representative of long-term arsenic use. So there was some negotiation. They determined that arsenic testing would be required, but not at the time of drilling. So our programs, our efforts, have been going on for about 25 to 30 years. We call them community drinking water programs. They involve locally working with extension agents or county conservation departments, where we advertise and we distribute bottles locally. The homeowner that agrees to participate will collect the sample, drop it off locally. Those samples are driven to our lab in Stevens Point, where we analyze them, we package it together. I'll drive back to that community and give a presentation to help them interpret those results. In a well-advertised program, we expect that who wouldn't want to test their well? But in a well-advertised program, and by well-advertised, I mean kind of direct mailing is still probably the most effective advertisement that we have. About 10% of the people in that targeted area will participate. Funding, grant opportunities might bump that up a little bit, but again, probably not as much as you would expect. And one of the goals of our programming is really to empower well owners to become their own water utility manager. And with that comes along a certain amount of responsibility. So I try to relay what that responsibility is. The cost of those programs really is paid for by the participants. So the basic package is roughly $50. And I think most people, generally who participate don't complain about the cost too much, and they feel that that's a pretty good value. Again, grant opportunities are scarce in Wisconsin for this type of work. When we find them, again, they do increase participation, but sometimes the feedback from that, when we ask people, well, are you going to test again? And they say, well, sure, next time you offer the subsidized or the free testing, I'll test. So it's kind of a catch-22 in terms of the testing. If you can find funding, it's great because you can collect some baseline information. But long-term, what effect does that funding have on kind of good practices for well owners? And it's a decision that every community has to balance, I think. If we look at the last part of these efforts, it's that educational program. So if we're talking 12 to 15 of these programs throughout any year, each of those programs averages between 80 and maybe 150 participants, which is our max. If we talk about how many of those actually attend the educational program, it's roughly 50% of participants. So 50% of households. We might get more than that attending because households will often attend in pairs. So the husband and the wife will attend together. So our participation is roughly half or a little bit more in terms of number of people versus participants. What we know about those efforts is that they seem to be successful in terms of some of the metrics. So 91%, this was past participants versus random people in a county that we work in. 91% of survey respondents who participated were likely to indicate they planned on testing again, compared to 65% of the random population. And only 1 in 10 respondents who participated said they lacked or didn't have adequate information, compared to roughly 1 in 4 of the randomly selected participants. So it does, I think, either show success, or it shows that the people that participate in these programs maybe are more inclined, or are more knowledgeable to begin with. That's a little bit unknown, but I like to see a little bit of positive results from these efforts. When we look at the data collection side of things, which is I'm going to focus on that for the rest of the presentation, much of the information has been collected through our extension efforts. This shows a summary of that information. Obviously, coliform bacteria and nitrate are the highest in terms of number of samples we have. We're approaching about 100,000 samples in our database alone. The homeowner package does include a series of other constituents, though: chloride, alkalinity, conductivity, hardness, pH. That homeowner's package is the baseline $49 package. In the late 90s, we added a metals package, which is another $49, 11 different metals and minerals, including arsenic. And then there's a triazine screen, which is $27. It's an ELISA-based method for looking for a breakdown component of atrazine, diaminochlorotriazine, which at least in Wisconsin seems to be more prevalent in groundwater, and a better predictor of total atrazine, which is what Wisconsin regulates atrazine on. Some states, the atrazine standard is parent atrazine of 3 parts per billion. In Wisconsin, we regulate, our health standard is based on total atrazine, so atrazine plus the combination of all its breakdown components. And diaminochlorotriazine seems to be a better predictor of that total atrazine residue. So when we talk about what to do or what we've done with this data, I like to use the analogy of the first water sample that was collected, and using the analogy of an ant. So you have that first water sample. Somebody had to take the initiative to take that first grain of sand and put it somewhere. And there's multiple entities that are collecting data. Our lab is only one of a series of places where there might be data housed. State Lab of Hygiene is big. We have a couple of local health departments that collect and analyze samples. DAGCAP. Private laboratories are also a consideration. Our ant is that gentleman on the lower left who received an award for his work. Much of what I'll present is his work. We've been fortunate in that our database manager, who I'm affectionately referring to as our ant, worked for the last 30 years. He recently retired, but a lot of that archiving took place by one individual. So that consistency and that dedication to maintaining that database has been really key. When we look at some of the challenges of summarizing or using and utilizing data, it's that data is stored in those various locations. So we have some at DNR, we have some at DAGCAP. Our data that we have, there's county health departments, and then there's others which not easily accessible or maybe not willing to share. So we spend some time working with all the stakeholders, figuring out a way to try and put some of these tools together. And there was a lot of challenges in terms of different entities wanting to share that information. And each entity had their own legitimate concerns for why they might not want to share their data. So we have these different piles of sand that are located in different areas. And the challenge is, how do you bring those different piles together? How do you sort them? Each lab is collecting something a little bit different, but most of them are collecting things like bacteria and nitrate. So how do we put those piles from those data sources together in a way that is useful? And we sat through a number of meetings, again, with stakeholders trying to do that. And a lot of those meetings ended in disappointment or failure, and nothing getting done. So eventually our center, mainly Dave, our database specialist, just said, you know what, we have enough publicly accessible information that I can download and enough in our database that I think we should move forward without necessarily working hand in hand with a lot of the other entities. So he mainly took that next step in terms of seeing what we could do, what are the possibilities of it. And legitimate concerns, multiple data formats, different levels of quality. Much of the information is voluntarily submitted. So it's various levels of quality associated with that, various levels of uncertainty. And then each lab might have different detection levels, which make compiling or putting that data together somewhat challenging. So when we have those, so this slide shows, separating that data into the different parameters or constituents. So we have these different parameters, and then the challenge is how do you put it together in a way that can paint a picture or give a visual of what those individual parameters are for the state of Wisconsin. And here, the analogy of building a sandcastle is really appropriate in that for something like nitrate, we have a lot of data. So that picture, that visualization that we create is going to be much more detailed than something like arsenic, which hasn't been collected for nearly as long. We can still create a picture. That picture in the lower left, you might still be able to tell is supposed to be a sandcastle, but it doesn't have the same level of detail as something that we've been collecting very methodically for a long time. So we've created what we call the well water viewer. And it allows you to search for 14 different parameters that we have data for. It allows you to search, it aggregates the data by county, by town, and by section. So there's different levels of detail. It's an interactive mapping tool that you can utilize to look at different levels of detail. And it also allows you to generate tables of the data for any user-defined area of a minimum size. Some of the reasons we don't display individual dots on a map is that, again, it's voluntarily submitted, so it's difficult for us to verify that this sample did in fact come from this dot on the map. There's also the privacy concerns, which we felt aggregating the data allowed us to get around those challenges. We were pretty confident that the wells were located at least down to a section, for sure down to a town range, and definitely we could identify the county that it came from. So that allows for us to aggregate it with a certain level of confidence at those individual scales. This is showing the visualization of nitrate by county. This is showing it at a town range level. Again, for nitrate. So the different colors are representing the different percent exceedances. So the percent of samples in that area that exceeded the nitrate standard, or were greater than the 10 milligram per liter nitrate standard. You'll notice that any region which is colored means we have sufficient data. We feel we have sufficient data to characterize that particular area. The areas that are blank are indicating that there's not enough samples. If wells are the window into our groundwater, there's either not enough people that have tested, or there's just not a high enough density of wells in that area to generate, with any confidence, an average level. And those blank spots on a map are actually pretty useful. When I go into a county, I'll utilize this tool, and I'll zoom in on a county, but I'll make sure to include the neighboring counties. And counties can be pretty competitive. So if they see a county adjacent to them with a lot of filled-in region or filled-in area, they'll often ask, well, why does the neighboring county have so much information? And it's an opportunity to talk to them about some of the outreach or the programming that they've done, or maybe some of the assistance that they've provided to build up that data set. In other areas, it might be because the county lab hasn't shared that information with us. So there it's an opportunity to tell them, well, we could fill in this map a little bit, but it would be up to the county to work with us to get their data into this system. And that's been a really effective tool for building those partnerships and collaborations. So this is just another map showing nitrate. Again, this is one of the ones we have the most extensive data for. Here's hardness. And here's looking at kind of a zoomed in version at a section level. So again, that user-defined area, if you generate a circle or draw a circle, that table on the lower left is showing how many samples we have from that particular area and the different categories of the different breakdowns. Another feature is that you're able to do different overlays. So one of the underlays or overlays would be the aerial photograph. And there's a transparency tool that people can use to see what is the underlying land use associated with the different water quality. We track statistics over time. So on any given year, we estimate, about I just looked at it last night, there's been, within the last year, about 5,000 people that have utilized the viewer. 30% of those are return users. You'll see spikes that correlate to different news stories or resources that kind of distribute the link for the viewer. So we do see spikes when that generates some media coverage. And we know that the average person that clicks on the actual database link is spending anywhere between about 2 minutes. The average is just over 2 minutes. So it could be a couple seconds if they go in and they click out right away. But in general, most people are spending a couple minutes, even up to 20 or 30 minutes. And I know when the link goes down because I'll usually get a call from somebody that works for DNR or maybe a consultant that relies on the viewer pretty routinely to access information. So we know it's being utilized pretty effectively, and we can see kind of the referring websites. A lot of times those referring websites might be different agencies or different counties that also include the link on their websites for folks. So there are some strengths in that it's been really amazing at allowing access to the information that we have available. It provides transparency, so different communities are looking at the same information and utilizing and printing those maps off when they're having discussions about potentially controversial issues. Obviously highlights the need or areas where we need more information or data, and it allows us to focus resources more effectively. Here's just showing that relationship between land use and nitrate. It's really been powerful for helping illustrate, the role of land use and geology in determining a community's nitrate risk. Arsenic, we can show pretty definitively those areas that have a higher risk of arsenic. A lot of white on that map, so there's hopefully with the new regulations, over time we'll be able to fill some of those white areas in. Hardness obviously shows a very strong correlation to those areas where we have carbonate aquifers. So again, a valuable teaching tool for talking about the relationship of geology to groundwater quality. And then pH, if we were to look at pH statewide, it would show that Wisconsin doesn't have much in the way of pH or corrosivity issues. But if we look at it at a finer resolution, there are some areas where pH is in the 6 or even lower range, which tells us that those areas do have a heightened risk of corrosivity and lead and copper. Manganese, somebody mentioned yesterday, there's an aesthetic level for manganese, but Wisconsin also has a health advisory level of 0.300 milligrams per liter or 300 parts per billion. And there are parts of the state that a number of wells would exceed that health advisory level even. So current data limitations, there are obviously a ton of data limitations. The pictures that we showed represent data from the last 30 years. We all know groundwater quality can change, but if we were to parse out that information and separate it out by decades, it would really start to degrade the resolution of that portrait or that picture. Most of those wells have only been tested once, so we know that answering the question of how is groundwater changing is really difficult to answer with this particular data set because there's just not that repeat methodical testing that's been done. Well construction for a lot of this is largely unknown, so determining if it's deeper or shallower groundwater, where the contamination issues are coming from, is obviously challenging. And trends. That's another thing that this database really isn't useful for looking at. So the picture on the right, I think, is a good visual. Once you create that picture, people are really impressed, but then they look at this car on the beach and they say, well, that's great. but I want to be able to get into that car and drive it now. So that's where some of the questions about, once they see that picture, their wheels start turning about, well, I want to know, is groundwater getting better or worse? And again, this is an opportunity to talk about why we can't do that, but maybe how moving forward you might be able to set yourselves up or your community up to answer those questions. So future directions, obviously we're going to continue to collect that baseline level of data and fill in this map and get it to as much detail as possible. But I really do like and enjoy working with communities to develop approaches that will allow them to focus on areas and answer those questions. How do we collect data in a way that 10 years from now, we'll be able to understand if it's better or worse? And areas are able to do that. It just takes a little bit of guidance and a little bit of foresight. And if they do have any limited funding available, I often try to encourage them that their funding is probably better utilized in those ways as opposed to kind of a scattershot approach to well water testing. So with that, I think my time is almost up, but I hope we have time for maybe one or two questions.
Hi, Todd Drifsinski with the Kendall County Health Department in Northeast Illinois. When you show maps of the sampling, one of the things we struggle with is we may get a detect of something, the person may treat, and then they'll sample again. And with our current GIS stuff, we can show the numbers on each individual parcel that we can see internally as far as what the detects were. When you show some of the color-coded maps, are you using maybe an original sample, or for those wells where you have multiple samples, are you using the first sample or the most current?
That's a great question. So in terms of when the maps were created, we did do some initial investigation. How many repeat samples were there? Could we separate out and limit it to the most recent? That happens, but for the vast majority of wells, probably 98% or more, we only had one sample. So the decision was ultimately made just to include everything, looking for some maybe anomalous wells where we might have 5 or 6 samples, especially if those samples were really high in a particular contaminant that might skew the database. Those were pulled out, but in general, the amount of time needed to separate out for the most recent sample would have made this a almost impossible task. So the power really is in the aggregation of the data, and any of those instances where we have multiple samples, I think there's enough that it's not going to dramatically affect the patterns that we see. But moving forward, that's an obvious area for improvement, which having that unique well identifier, I think will help us get around. But that's any well drilled after 1988, which moving forward is going to be increasingly a larger percentage of our data. But this was focused on how do we utilize what we currently had.
Hi, this is Dave Harvey from the Indian Health Service. So I heard 2 talks about the people aren't coming to get their well tested with free water testing in Pennsylvania and in Wisconsin. So maybe this is for everyone. I mean, there are other programs that are kind of targeted towards vulnerable populations that may be leveraged in these efforts. So was there any thought to do that, like the WIC program, for example, is one that comes to mind, either in Pennsylvania or in Wisconsin?
So our WIC program does offer fairly targeted testing through the county health departments. So when they're notified of a pregnancy, they will work directly with that household to have the water tested. So we didn't necessarily leverage those opportunities for these programs because there's some strict requirements in terms of where they send the sample and how that data is collected. But we do try to mention those opportunities whenever possible. We've tried various models, so working at a town or a county scale. Recently, we tried working with a school, an elementary school, to offer testing or advertise the testing to families at that school. It was a rural school. Why do people not participate? You'd expect that population to be maybe more engaged in having water tested. But we saw very low participation from families. And I suspect partially cost, but also time. And are they available at the time they need to pick up a sample bottle and drop it off? Are they available to attend the program? And when you're talking about why people don't participate, I'd say, in any targeted area, you want 100%. Realistically, about half of those people would probably participate in a government-run or university or locally run program. So you're automatically limiting your population by almost half. And then when you start talking about cost and time and scheduling, I think that's why we're looking at 10% participation rate in a well-advertised program. In a program where we've offered to mail them the kit and they mail it back, we were looking at about 35% participation rate. On the first initial mailing, we were able to bump that up to about 50% after a second or a third mailing, where we offered a completely free test where all they had to do was collect the sample and put it in their post office or their mailbox. So again, 10% sounds low, but over 30 years, we've been able to collect a tremendous amount of data that I think is pretty useful. You got to start somewhere, and that's my recommendation to any community that I work with.
All right, quickly, do you get requests for data? And what do you do? Is it public or is it FOIA?
That's a tricky question. We do get requests for data. One of the reasons we created the viewer was because we get those requests, and now we can forward them to the viewer and say, well, go here first. And that satisfies probably 90% of the requests that we get. Occasionally, we'll get a request from a law firm or a county asking for actual individual well records. And we've been pretty successful at deferring those or sharing it at a level of detail that doesn't give away the individual parcel or property. Again, it's voluntarily submitted data. So if it were to come up in a court of law, we could not verify that, in fact, that sample came from that individual parcel. So it would be irresponsible to share it in that manner.
Thank you. All right, thank you.